Okay, so let's look at question 6. In question 6, the question is saying a radiographer, baseball player with mass equals to that, sliding into a second base, second player, I guess, is retarded by a frictional force of magnitude 470 Newtons. What is the coefficient of kinetic friction between the radiographer and the ground? Okay, so let's see what is happening here. So we have two players. This is the first player with that given mass. This person is sliding, this person slides into a second player. So these two are going to collide. And then the first player is retarded by a frictional force of that magnitude. Now the question is, what is the coefficient of friction between the first player and the ground? So the fact that, let's first get what the question is giving us. We have the mass. So the mass of this player is 79 kgs. And then what else? Retarded, sliding into second player is retarded by a frictional force, like giving us the frictional force causing this person to stop. By retard, this is just saying the speed is reducing. So retarded by a frictional force of 470 Newtons. And then what else? What is the coefficient? We're looking for the coefficient of friction. So that is something like this. Oh, yeah, that should be okay. So we're looking for the coefficient. So this question is a little bit vague. They don't tell us a lot of information here. So that is really not going to help us much. But the first thing that we have to do is to sketch the problem. So we have to sketch the problem so that we understand what is happening there. Okay, so after collision, you see, you don't really even have to think about what is happening during collision and so on. That is going to be a topic for later. But all you have to see is this person, whether they stick together or what, this person is literally just on the ground. This person is on the ground. I can even draw the person as an object. So as an object, of course, we have the mass going down. So the weight will act downwards. And then from the ground going up, we're going to have the normal force. Remember, I always say the normal force will always be a reaction force that comes from the surface onto the object. So this person is being retarded. If motion was in the forward direction, what happens here is that the retardation or the retarding force will have to be backwards. So let's assume the person is going forward. The retarding force will have to be going backwards. Okay, so this is the only force that is acting on the person. So yeah, that's all we have. Now, what is the question asking us to find? The question is asking us to find what the coefficient of friction is. So when we start with what the coefficient of friction is, the definition, remember how it goes. The coefficient of friction is just equals to the force of friction itself over the normal force. So this is all we need if we're going to get the coefficient of friction. Now the question is, do we actually know these two quantities? Do we know what the force of friction is? Do we know what the normal force is? So in this case, let's try to see, where do we get the normal force from? So the normal force is going to come from the vertical axis, the y-axis. So in the y-axis, we only have two forces. So we sum the forces there. Sum of forces in the y is supposed to be equals to ma. But you know, to say the object never goes up in the y, it never goes down. This person is sliding on a level surface, implying that the acceleration in the vertical axis is 0, which makes the right-hand side just a 0. So that in the end, we only have the sum of forces, like the way the other two of them equals to 0. So going up is going to be Fn, going down is going to be mg. This is what will be equals to 0. From here, we can get this. We know what the mass is. I think I copied it somewhere. Let's cut this. From here, we can just make Fn the subject of the formula. We now have Fn is equals to mg. So we go back to the question to get what the mass is. I copied it, but I didn't put it down. The mass here is given as 79 kgs. So you have the mass is given as 79 kgs. And then the retarding force F, or the force of friction, is given as 470 newtons. So we can get these two. So with the mass figured out, with the mass given, we can easily substitute to get what the normal force is. So the normal force becomes 79 multiplying G, and G is 9.8. So what will be the answer here as I look for my calculator? Can someone do this very quickly? What will be the answer there? So 79 by 9.8. Okay, so here we're getting 774.2 newtons. So this becomes our normal force. So remember, we are working with the coefficient of friction being equals to the force of friction divided by the force normal. We have just found what the normal force is, and we have found 774.2 newtons. The only thing left here is the force of friction, which is the retarding force. The question did give us what the retarding force is, and it was given as 470. So I can just get this 470 and place it here, and then divide so that we can get what the coefficient is. So if we did that, what we're going to have is 470 divide this by 774.2. So if we do this, we get 0.607. So this becomes the coefficient of friction. And remember what I mentioned last time. The coefficient of friction is a very small number. It should never exceed 1. So it's the maximum it can ever be, the 1. So if not 1, it has to be less than 1. So that is what the coefficient of friction is. So with this done, we can move on to question 7. So do we have any questions before we go to question 7? Any questions here before we move on to question 7? Okay, so let's go to question 7. In question 7, they're saying that we have both is a female student majoring in pharmacy at the university. She pushes horizontally with a force of 220 newtons on a 55 kg crate containing medical supplies. So all I'm seeing here is that this person is pushing horizontally with a force of 220 newtons. Whatever they've said there is just a little bit extra. Of course, on a 55 kg crate, they're even giving the mass of the crate here. So I want to take note of that. Then apart from this, crate containing medical supplies to move across a level surface. So the crate is moving on the horizontal surface, meaning it's not moving in the vertical. Then what else? The coefficient of kinetic friction is, so here they're giving me the coefficient of kinetic friction, that is 0.35. What is the magnitude of A, the frictional force, B, the crate's acceleration? So I'm looking for force of friction here, and I am also looking for the acceleration. These are the two things I'm looking for. So once I have this information, the starting point, of course, is to picture the problem so that I know what is happening there. So this part has been given. Now, let's try to just picture what is happening in this case. So what we have is a horizontal surface where this object is being pushed. And the object itself, let's assume it to be something like this. So this object is being pushed on a level surface like this. the force causing the push or pushing this object, it's a horizontal force, and the question specifies this force to be 220 newtons. Now, this object is supposed to move on this horizontal surface. And we know to say, if friction is present, friction is a force that will always oppose motion. Since motion is to the right, we expect friction to be backwards to the left. So we can assume frictional force will actually be in this direction. So apart from frictional force, we know to say there will be two other forces. One force will be the weight of the object going down. The other force would be a reaction force coming from the ground going vertically upwards onto the object, and that is the normal force. So these are the four forces which will be acting on this object. So how do we proceed from here? Well, we have to sum forces. We're going to use Newton's second law. F is equals to ma, but we'll do it in the x-axis. This is in the x, and then we'll also do it in the y-axis. Sum of forces in the y equals to ma in the y. So in the x-axis, I count two forces, the 220 to the right, Ff to the left. I'm going to have 220 to the right positive, force of friction to the left negative. This is what will be equals to ma. So just write a here to mean the acceleration in the x-axis. From here, we see that we can easily find force of friction if we know what the others, what the mass and the acceleration are. The question does give us what the mass is. The mass is 55 kgs. So this equation becomes 220 minus force of friction equals to, that's 55? Yes, 55 kgs. So you have 55 times A. So you just want to make sure that the mass you're using is actually in kgs. So I'll make FF the subject of the formula here, which becomes 220. The 55A will cross, so it becomes negative. The force of friction will go the other side and it becomes positive. So that the force of friction is equals to 220 minus 5A. I hold on to this because I need the acceleration to actually find what the force of friction is. Let's go in the y-axis. What is happening in the y-axis? Well, in the y-axis, we see that we have those two, the normal force and the weight of the object. So if I sum the forces in the y-axis, the normal force will be going up, the weight will be going down. This is what is supposed to be equals to mass times the acceleration in the y-axis. But remember, the question says the object moves on a level surface horizontally. It never goes up, it never goes down, meaning the acceleration in the y-axis has to be 0. So that in the end, we only have Fn minus mg is equals to 0. Lastly, the force normal will now be equals to mg when the mg goes the other side. We know what the mass is, so we can easily find what the normal is. The mass is 55, g is 9.8. So doing this gives us Fn. Let's see what it gives us Fn as. So that is 55 by 9.8. So we get 539. So we now know the normal force, but how helpful is the normal force? See, the question did give us the coefficient of friction. So using the coefficient, we know that the coefficient of friction is equals to the force of friction over the force normal. So in fact, we see that if we know what the coefficient is, 0.35, we can easily say 0.35 is equals to the force of friction divided by our normal force we just found, 539. So I can say this is 539. We can cross multiply here so that we have 0.35 multiplying 539 to give us what the force of friction is. So that the force of friction here comes out as, when we multiply this by 0.35, we get 188.65. So this becomes the force of friction. So having found the force of friction, the question also asked for the acceleration. To find the acceleration, we come to equation 1. We now know that we could have actually found the force of friction without summing the forces in the x-axis. But we're glad we did that first, because now we can just, where there's force of friction, put that 188.65, because that is what the force of friction is, then equate it to 220 minus 55A. But we'll just make this the subject of the formula. So I'll cross it to the other side so that it becomes positive 55A. Then I'll take the 188 to the right, it becomes negative. So I have 220 minus 188.65. So if I get the difference here, minus 188. 188. Okay, so that's minus. Okay, so we get 31.35. Then divide this. So this is now 55A is equals to this. Divide both sides by 55. Doing this, we get A is equals to, that's 55. We get 0.57. This is acceleration, so we have meters per second squared. So this becomes the acceleration of this object. So this is how it goes when it comes to question 7. We've answered both A and B. Any questions there? Okay, so I hope you guys are seeing that most of these questions are actually very, very basic, and the approach to working them is really just the same. So let me see. I will skip some of these because I feel the methods are the same. Question 8 seems to be something also very basic, similar to what we have been doing so far. But I'm saying question 8, they're saying the coefficient of static friction between whatever this is and the scrambled eggs is about this. So I'll just give you guys the skeleton of how you approach it. So you have 0.04. What is the smallest angle from the horizontal that will cause the eggs to slide across the bottom of this coated skillet? So yeah, all you have to do here is create a free body diagram again. Just place an egg on the table. Don't even treat it as an egg. Forget about it being an egg. Just take it to be just one object. And then you want it to slide in some direction. Perhaps we should do it. Would you guys want us to do this question? Would you guys want us to do this, or something that you guys can do? Okay, let me just sketch it. Just picture the egg to be something like this. It is on a horizontal surface. Let's pick that to be our horizontal surface. Now, the question is saying the smallest angle. So it's like the egg is being tilted. As in whatever this object where the egg is, where the scrambled egg is, it's being tilted. So let's assume that it's going to be tilted up to something like this, such that our scrambled egg is now here. So I don't want it to be like that. Okay, so something like that. So if the scrambled egg is going to slide, what will cause it to slide? Notice that according to the question, there is no force which is being exerted here. It implies that the only thing that makes the egg to slide must be its weight. We know to say the weight will be acting vertically downwards, which is mg, but we know to say we can easily break the weight into components. We always pick the vertical axis, or the axis perpendicular to the surface, to be the y-axis. Perhaps let me get this. what makes this question kind of interesting, or why I decided to work it out in the end, even though I wanted to skip it, is the fact that they actually don't give you what the mass is in this type of question, because you don't even need the mass. It will cancel out eventually. So this is question 8. So what you have is something like this. So what you want to find is the angle here such that the egg is just about to slide. Now, how do you proceed from here? So you know to say the new y-axis will have to be an axis perpendicular to the inclined plane, something like this. And the new x-axis will have to be something like this. So I will just move my x-axis so that it passes right on the middle of that egg. So based on that, based on our description last time, we know to say this weight mg can be split into 2 parts. One part will be a component that will be heading down the inclined plane, and one part will be a component of the weight that will be pressing it against the inclined plane, like that. And then apart from these two, we also observe that there will be a second force in the vertical axis that will be a response from the surface going upwards. This is the normal force. Notice that on an inclined plane, I keep maintaining the normal force to be perpendicular to the surface. So if an inclined plane is like this, the normal force will have to be perpendicular to the inclined plane like this. So just wanted to emphasize that again. So in this case, observe that in the x-axis, there is no other force that is given. You only have the weight of the object that will act in that direction. And the other thing that I mentioned last time is, if the angle here is theta, then the angle here will also be theta. This is what enables us to say the force here, the component of the weight here, will be mg sine theta. I think I already showed you guys how this goes. And in the end, I mentioned that you can just take it that the component of the weight that will always be in the x-axis for an inclined plane will always be given by this. It will never change. It will always be given by this. Unless if the angle you're given is not this, unless if they give you the angle that is this side, then here you're going to have cos instead of sine. But if the angle given is this one here, then you know here you always have sine. Okay, so you have sine here, and here, going downwards, you have mg cos theta. With this in mind, let me erase everything else, the inclined plane and so on. So just look at the object itself. So if I removed everything else, look at what we now have. We see that for our object in the x-axis, or let me say in the y-axis, if I summed the forces in the y-axis, sum of forces in the y-axis, and say this is equals to mg, in the y-axis, the object never goes up, it never goes down. So not equals to mg, equals to ma. In the y-axis, it never goes up, it never goes down. So in the y, the acceleration is equals to 0. So there are two forces in the y. We see that we have Fn going up, mg going down. So we have mg cos theta going down. So this has to be equals to 0. From here, we see that Fn will be equals to mg cos theta. This is our normal. The next thing is in the x-axis. In the x-axis, we only have this part. This is the only thing that we have. Okay, so that's the only thing that we have in the x-axis. So we'll see if we will actually need that part. The only thing, in the y-axis, in the x-axis, there's another force that is present, and I am concluding that that force is present based on the fact that they've given us the coefficient. If the coefficient is given, it means that friction is present. So in the x-axis, we conclude that friction is also present based on the fact that we have that coefficient of friction. And if it is about to slide down, then friction will be trying to prevent that, and friction will be going in this direction. So I am including friction because of the presence of the coefficient. Above all, when you are trying to tilt this inclined plane, the only thing that prevented the egg to slide in the first place is the presence of friction. So for it to slide, it means that the force pulling it down must have just exceeded friction. Okay, so let's sum the forces in the x-axis. And what are we going to equate this to? Now, because this object is just about to start sliding, it means that it hasn't started sliding yet, implying that it's not accelerating yet. So even in the x-axis, this has to be equals to 0. Because of that, if we take down to be positive, down the inclined plane, we're going to have mg, the positive one, sine theta, then minus the force of friction. This will have to be equals to 0. So that in the end, we can say mg sine theta is equals to force of friction. So this becomes number 2. You observe that whenever there is force of friction involved, we always say first some forces in the x-axis, then some forces in the y-axis. And the connection between them is always through that force of friction, because we know to say the coefficient of friction will always be equals to the force of friction divided by the force normal. So if you know the expression for the force normal, then you see that where there is force of friction, you can easily make this substitution. The force normal is here. So where there's force normal there, I'll put mg, because I'm saying force normal is equals to mg cos theta there. So I'll put mg cos theta here. Now again, the only thing we know is the coefficient. We don't know what the mass is. We're looking for the angle. So now I can say this is my equation 3. My goal now would be to solve equation 3 and equation 2 together, because you see they've got a number of things in common. So I'll get equation 2, which is this. And where there's force of friction, I'll make the substitution, or I'll plug in equation 3. Because from equation 3, force of friction was given by that. So now this becomes mg sine theta. And where there's force of friction here, I'll put this. So I'll put mu mg cos theta. Now we are almost done. Notice that the mass here was in fact not necessary. So it falls off. From here, observe also that g is present on either side of the equation. So g also falls off. We now only have, let me just make sure g actually does fall off. So this is force of friction is equals to mg cos that. Okay, yeah, it looks like it does. So we now have sine theta being equals to mu cos theta. Now, how do we find theta here? Divide both sides by cos theta. We end up with sine theta over cos theta being equals to the coefficient of friction. And if I was to make this, you know what this is? Sine over cos, that is tan. So this is tan theta is equals to the coefficient of friction. We know what the coefficient of friction is. The question gives us what the coefficient of friction is, and that is 0.04. So we can get that and put it here. We now have tan theta is equals to 0.04. So that in the end, theta will be equals to tan inverse of 0.04. So I haven't seen my calculator, so I won't be able to evaluate this. You guys can try to finish it from here. Okay, I thought this was going to be interesting. That's why I decided to do it. So I hope you guys were able to appreciate how this actually resolves. Okay, any questions before we proceed? Okay, looks like we don't have any questions. Okay, so next up, that was question 8, was it? That was question 8. We have 2 more, then we are done with this. So question 9, when 3 blocks in the figure, are released from rest, they accelerate with a magnitude of 0.5 meters per second squared. Block 1 has mass m, block 2 has mass 2m, and block 3 has mass 3m, 2m, I mean. What is the coefficient of friction between block 2 and the table? So this question is very interesting. And I think this is going to be the last one that we're going to do in this tutorial sheet. You guys can try to pull out this later on. I will work it out and upload it as well in a complete document, but you guys can try it out. Okay, so let's see how this goes. So you have to observe what is happening here. This object, if you look at mass 1 here, it's just hanging. So if I was to look at mass 1 on its own, it will experience its weight to drag it down. For mass 1, what we have as its mass, where is that? 3 blocks in the figure. So they are accelerating at this rate. Block 1 has mass m. So the mass for block 1, I'll take it as m. So the weight will be g here. And then holding it up will be the tension T. Now, because this system, the pulleys here are assumed to be massless and frictionless, it implies the tension along this string will be the same up to that side. So if I say this is T, I expect this to also be T here. Okay, what else is happening here? So I can even say that this is T1. So that if this side I have T1, then I can say this side I have T2. Okay, so this is just for block 1. Now, next, let me look at block 3. What is happening this side? So if I try to create a free body diagram for block 3, what you see here is that block 3 will also have its weight dragging it down. And what is the weight of block 3? I want mass times gravity. So block 3, the question says, and block 3 has 2m as the mass. So for block 3, the mass is 2m times gravity. So it will be mass times gravity. So the weight becomes 2mg. That will be the weight for block 3. And holding it up, observe that I said here, the tension here, I've labeled it as T2. So holding it up, that is going to be T2. You know, tension will always act away from an object. So if you have a rope there, tension will act away from that object. That is why from block 3, it is acting away from it. So this is done for block 3. The only thing left here is block 2. What is happening to block 2 here? If I was to now focus on block 2, let me put block 2 here. What you see here is that block 2 is on the table now. It will first experience tension T2, pulling it to the right. Again, tension always away from the object, so to the right. It will experience T1, pulling it to the left. But there will be another force present here. Because they're saying, what is the coefficient of friction between block 2 and the table? This is a hint that friction is present here. So the fact that we are looking for the coefficient tells us that friction is actually present. So friction is present between block 2 and the surface. But where is friction pointing? So here it will be up to you. If you choose positive to be this side, then it means that friction, it will mean that this object is accelerating to the left. Friction will have to be to the right. But in this case, we will assume that when this acceleration is given, they mean this object is accelerating in this direction. If it is accelerating in this direction, that becomes the direction of motion. So friction has to be backwards. So friction has to point in this direction. So this is what we have. And the mass for block 2 has mass 2m. So according to this, block 2 has mass 2m. So I will put 2m here. Okay, so block 1 has mass m, block 2 has mass 2m, block 3 has mass 2m as well. Okay, so I'll just copy this. I'm looking for the coefficient of friction between block 2 and the table. So I have everything I need now. Time to do some work. So this is question 9. It's up to you where you want to start, but I'll start with block 1 here. So for block 1, we see there's nothing happening in the x-axis. Everything is in the vertical axis. Now, remember how it goes. Since I've decided to choose for block 2, I've decided to choose this direction to be positive. So it means that I am following this to be positive as it turns to pass through block 1, then it will be positive as it goes down. So this yellow line is my direction of what is positive. So when I come to block 1 here, I observe that it actually agrees. T1 is going up, so T1 will be positive. I'll say T1. Then mg will be negative as it points down, so I'll say mg here. This is what will be equals to the mass of block 1 times the acceleration of block 1. So this is what we have. We're given what the mass here is. So you can easily say that T1, I can even take it that side. T1 will be equal to the mass. The acceleration is given. What is the acceleration again? Did I write it down? I did not. Let's get the acceleration. So the acceleration is given as 0.5 meters per second squared. So that is 0.5. So this is going to be equals to 0.5 meters per second squared. So that's the acceleration multiplying m. Then the minus here becomes positive. So this will be plus. And this becomes, when it goes the other side, the g is 9.8. So I'll say 9.8. And the mass here is going to be m. So I'll say this is my equation 1. Next, I'll come to block 2. I now want to do the same. I want to sum the forces for block 2. For block 2, the thing is you also have forces in the vertical axis. You have the weight going down, and the mass is 2m times g. So this is going to be times g. In the vertical axis, block 2 is on a surface. So the surface will react, and it will give it that normal force Fn. So let's see what is happening to block 2 in terms of sum of forces. So for block 2, I wanted to do this last, but anyway, I've already got it here. So for block 2, let's sum forces in the y-axis first. It's up to you where you want to start. It's not going up or down. Block 2 is sliding in the horizontal direction. So the acceleration in the y will be 0. So Fn goes up, positive, minus 2mg going down. Then this will be equals to 0. So that Fn will be equals to minus 2mg. So not minus, that will be positive. It will be positive as it goes the other side. So that in the end, Fn becomes equal to 2 times g. G is 9.8. So it becomes 19.6 m. So this becomes the expression for the force normal. When I sum the forces in the x-axis, so sum of forces in the x equals to ma. The mass here is 2m. The acceleration is a. So I can sum the forces in the x. I have T2 to the right, so T2 will be positive. T1 is to the left, so negative. And then there's also force of friction here. So force of friction will also be to the left. It will be negative. This is what will be equals to 2ma. So you really want to hold on to this force normal. It will be helpful later on. From here, we see that we know what the acceleration is. So you have T2 minus T1 minus force of friction is equals to 2 times the acceleration. The acceleration is 0.5. 0.5 times 2, we get 1. So it becomes 1 times m, which is just m. From here, we remember our equation 1. Equation 1 from block 1. It was an expression for T1. So we can actually get this expression for T1 and substitute it in our equation the other side. So I'll get this because T1 has appeared here. So where is T1? I will put our equation 1. And what will I get? I'll have T2. Where is T1? I'll put 0. That's minus 0.5 m plus 9.8 m. In fact, these two can actually add up. This is equals to m. These two can actually add up. So what are we going to get there? So we have 9.8, then plus 0.5. We get 10.3. So we have T2 minus 10.3 m. This, then we have minus here, force of friction. This is what is equals to m. Again, we see that these two can also easily add up. So I'll move the m to this side. I'll move this to the other side. So that I have T2 minus 10.3 m minus m is equals to positive force of friction. These two can also add up. We get T2. This becomes minus m. That's just 1 m. So it becomes 11.3 m is equals to force of friction. Now, from here, we know what force of friction is. The coefficient is equals to force of friction divided by force normal, implying that we can say force of friction is equals to the coefficient multiplying the normal force. Remember what the normal force was? We found it earlier on. Here, the normal force, we saw that was equals to 19.6 m. So the normal force was equals to 19.6 m. With that in mind, where we have the normal force in force of friction, we can put 19.6 m. So that this is just force of friction is equals to 19.6. Then we have the coefficient and then m here. We can then get this expression for force of friction and bring it here. So where there's force of friction, we're going to substitute what that is. So this becomes T2 minus 11.3 m is equal to, where there's force of friction, we have 19.6, the coefficient multiplying m. What you're trying to find here is the coefficient. So let's hold on to this as our second equation, because we can't do anything without knowing what this T2 is and without getting rid of what the m is here. So let's go to the only part where we haven't touched yet, which becomes block 3. So what is happening for block 3? You really want to be very careful when dealing with block 3. Remember the yellow line I indicated here? It was showing me what is positive and what is negative. So if I am following this yellow arrow, it means that I am positive, or that force will be positive. Picture these forces, or should I say these forces, T2. T2 was along the same direction as my yellow line, so it was positive here. T1, on the other hand, was in the opposite direction, so it was negative. Picture T2 for block 2 now. Observe that T2 for block 2 is in the opposite direction to my yellow line. To block 3, the yellow line is going down, meaning that anything that goes up will have to be negative. This is what actually confuses a lot of students, because you want to strictly take up to be positive and down to be negative. But here, this is a connected system, meaning if I choose positive to be up, it continues like this. This direction must remain positive for that continuous system. So these two are connected. I can't treat them separately. Even if I was treating them separately here, I still made sure that the influence on my positive was to be the same for all the objects, or all the parts. In other words, T2 will have to be negative because it's opposite to my yellow line. When I sum forces for block 3, then the 2mg will be the positive one because it is in the same direction as my yellow line. So this is what will be equals to ma. And remember, the mass for block 3, it's 2m. Then multiplying the acceleration a. So this is what is happening to block 3. So let's sum it up And let's finish what is happening there. The acceleration is still 0.5. So we have minus t2 plus 2mg is equals to 2m and then 0.5. 0.5 times m is still 1. So we have minus t2, 2mg. Then this becomes m. We simplify this. I want t2 to be subject. I'll take it the other side. 2 times g, that is going to be 19.6 m. Then minus m here. Then t2 goes the other side, becomes positive. These two can simplify, becomes 18.6 m equals to t2. From here, I can now get this and substitute where I had t2 here. So I'll just copy this expression. And where there's t2, I'll now put 18.6 m. So now I have 18.6 m where there's t2 here. So this remains the same. 11.3 m is equals to 19.6. Then m here. These two can now add, that is 18.6 minus 11.3. We get 7.3 m. So this is what is equals to 19.6 mu m. We see that mass is common. Mass can easily cancel out. We didn't need the mass. We now have 7.3 is equals to 19.6. The coefficient, divide both sides by 19.6. This cancels out so that mu will be equals to 7.3 divided by 19.6. We get 0.372. This becomes the coefficient. And remember what I always say, the coefficient must be less than 1. If you find anything that is not less than 1, then most likely you have made a mistake somewhere. Okay, this was quite long. Do you guys have any questions before we say goodnight? Okay, let's end here. Have a good night, guys.